Hello everyone! Today I will be presenting our physics project. For this project, our objective was to demonstrate the contrast of the magnitude of the rolling friction between two angles using a skateboard with different inclines around our ASU campus. Here you can see the first incline we used had a degree of 1. Using this recording, we then used the video analysis tool to analyze each video for position and velocity. As you can see, the image at the bottom right came from the video analysis tool, where it was decided to plot the points at the front wheel of the skateboard so that the position and velocity versus time graph could be determined. This is our first position versus time graph of the video from the previous slide. This graph shows how far the skateboard went over time from its initial position. As it can be seen, the skateboard is moving in a positive direction with a rolling friction. This is our first velocity versus time graph that was determined using the video analysis tool. This graph shows how fast the skateboard was going over time. From the graph, it can be seen that the skateboard was experiencing a small but constant speed over time. This graph shows a fluctuation which resulted from the bumps the skateboard experienced on the ramp, but overall, the skateboard was maintaining a constant speed. As you can see, the observed acceleration is close to zero, which means that was no acceleration, and the skateboard reached terminal velocity. Here's the second incline we used for the project, which had an angle of 20 degrees. Again, using the video analysis tool, points were plotted at the first wheel of the skateboard so that the position and velocity versus time graph could be determined. This is seen by the image on the bottom right. Similar to our first position versus time graph, this graph also shows the skateboard moving constantly in a positive direction over time from its initial position. The same trend can be seen for the velocity versus time graph to the first graph that was shown. Over time, the speed of the skateboard is showing a small but constant speed. Differently, this graph does not show much fluctuation comparing it to the first velocity versus time graph. This is due to the skateboard not having as many interruptions like bumps from the ramp that it was rolled down on. After obtaining our graphs for both the inclines, we then calculated the magnitude of the rolling friction. The equation used to calculate the magnitude of the rolling friction was as follows: Fx equals negative mg sin theta, where m was the mass, g the universal gravitational constant, and theta the angle of the incline. The mass of the skateboard was 2,000 grams, the universal gravitational constant was 9.8 meters per second squared, and the angle of incline 1 was 1 degree, while the incline of angle 2 was 20 degrees. The rolling friction of the degree 1 was calculated to be negative 342.08 newtons. The rolling friction of the 20-degree incline was calculated to be negative 6,703.6 newtons, and these were our calculations. Well, that concludes the presentation. I hope you've enjoyed it, and thank you for watching.